Hello and welcome back to video 2 for chapter 5. So what can go wrong? Avoid inconsistent scales either within the display or when comparing to displays. So for instance, here we have an example in the picture there of a graph that's doing a time plot, but the tuition plot starts in 1965 and ends in 1999. The college ranking plot starts in 1989 and ends in 1999, but it appears that they are on the same horizontal axis, which is misleading. Another problem is the vertical axis would have to be two different things, because Cornell University's tuition would have to be measured in something like dollars, whereas the university ranking is a ranking with other universities. Another thing is, with the question, why does college have to cost so much? The implication here is that as tuition is rising, something bad is happening, that Cornell's ranking has plummeted, it looks like. Well, what happened was their ranking went from 15th place to 6th place in academic rank. That's awesome. That's great. That's something that people want to have happen. So, yeah, this is a really misleading graphical display. Make sure you label clearly so a reader knows what the plot displays. Yeah, they may have had good intentions, but that is a bad plot. Beware of outliers. Be careful when comparing groups that have very different spreads. Consider these side-by-side box plots of cotinine levels. So no ETS, the smoker. Yeah, see how everything's all squished together for the first two? Something needs to be done. They could re-express the data. They could put another set of box plots with different scales, but everything clearly labeled. Something needs to be done to make comparison possible here. What have we learned? We've learned the value of comparing data groups and looking for patterns among groups and over time. We've seen that box plots are very effective for comparing groups graphically. We've experienced the value of identifying and investigating outliers. We've graphed data that has been measured over time against a time axis and looked for long-term trends both by eye and with the data smoother. Okay, so let's make a box plot of the data from the shoe example from last time. So if you want to get out your calculator, that would be great so that you can actually play around with it and make sure that you can do this. So the 17 women were asked how many pairs of shoes they own, and we have our answers. Okay, if you go to your data and statistics page where you have the box plot from before, if you didn't create one, create a data and statistics page and add shoes for the horizontal axis, and then tell your calculator that you want a box plot for the type of plot. And here we have a picture of it. Let's extend the shoe problem. Let's look at what 17 men said when they were asked how many pairs of shoes they own. So you'll need to either create a separate list in your document that you have for the women's shoes, and put shoes with an M for men's shoes, and make this separate list. And then you can add a third page, another data and statistics page, but this time choose the shoes for men as the variable, and then create a box plot there. So the men have 8, 2, 10, 6, 8, 12, so on. So I'll let you do that. Go ahead and pause the video and make your list. Okay, now make your box plot, and it should look something like this. All right. So now we want to compare the two distributions. Feel free to go back and forth between box plots and dot plots if needed. I find shape easier to read from dot plots, so that's the beauty of having the graphing calculators. Once you have the data in there, it's so easy to go back and forth between the different forms, and so you can read from the different graphical displays what you find easiest to read from them. Whereas it's easiest to read shape, I think, from dot plots. It's much easier to find the median and the quartiles and that sort of thing from the box plot. So here we have, I've got mine labeled where shoes W are the shoes for women and shoes M are shoes for men. So you can look, and looking at them, I mean, there's some things that really stand out. If you compare, the scales are not the same, so the overall range is a lot bigger for women. The median is much higher for women. So let's look at a comparison. Whereas the women's distribution appears to be skewed left, the men's distribution seems to be slightly skewed to the right. Neither distribution has an outlier. The median of the women's distribution is 20, is much higher than the median of the men's distribution, 9. The range for the women, 31, was greater than the range for the men, 19. The IQR for the women, 15.5, was also larger than the IQR for the men, 7.5. Okay, if you'll notice, I addressed everything in SOX: shape, outliers, center, and spread. Not only did I report what's true about each distribution, I made a comparison, a direct comparison. Notice, I said, whereas the women's distribution seems to be skewed to the left, the men's distribution appears to be skewed to the right. Made it clear that I compared and contrasted the two. Neither distribution has an outlier. That's fine. There's nothing really to discuss there beyond that. Notice I didn't just list the medians, but I mentioned that the women's distribution is much higher than the median of the men's distribution. On the AP exam, if they ask you to compare distributions, those statements that explicitly point out the differences are critical if you want full credit. If you just put the median of the women's distribution is 20 and the median of the men's distribution is 9, that's not enough. You need to indicate that you get that 20 is higher than 9. That may feel redundant, but remember, you're not just solving a problem, you're making it clear that you know what's going on. Communication is key. The range for the women, 31, was greater than the range for the men, 19. It seems kind of silly to have to point out that 31 is greater than 19, but you have to. The IQR for the women, 15.5, was also larger than the IQR for the men, 7.5. Again, you need to have that clear relationship stated there. The women have the larger IQR than men. So the women have a higher center and there's more variability. All right, let's look on page 97 at problem number 16. It's about gas prices. And this will make you very nostalgic for the early 2000s. Here are box plots of weekly gas prices at a service station in the Midwestern United States. Prices are in dollars per gallon, and they vary from a little over $1 to maybe a little over $2. Compare the gas prices over the 3 years as Part A, and Part B, in which year were the prices least stable, and we're to explain that. Okay, so for Part A, we're going to compare the distribution of prices over the 3 years. So for the median, you look at that center line going through the boxes. So the median price increased over the 3 years. Okay, so we did that. The spread is determined by whisker to whisker unless there's outliers, and then you also look at the outliers because that would be involved in your range as well. The spread increased as well, especially when you just look at the bulk of the data. When you don't look at the outliers, it becomes obvious that the spread is increasing as well. The prices in 2002 were skewed to the left with several low outliers. So remember, skewed to the left means skewed to the lower values. So there are outliers to the left there. In 2003 and 2004, the distribution became increasingly skewed to the right, where sometimes you had some more variability in the upper range than in the lower range of prices. There was one high outlier in 2004. So we discussed shape, we discussed outliers, we discussed center, we discussed spread, and we made direct comparisons in our statement. So we're good. In which years were the prices least stable? The year with the greatest variability has the least stability. Since 2004 has the largest range and IQR, it has both the greatest variability and the least stability. Even though there were more outliers in 2002, when you consider the overall spread, there was greater variability and the least stability in 2004. It was just really unusual in 2002 for there to be prices that weren't close to the median, and that's why the ones that are kind of far away are considered outliers, because it just didn't happen all that often. There wasn't much spread overall. So that is an important thing to keep in mind. All right, let's look at problem 18 on page 98, and we're going to look at fuel economy in cylinders. Describe what these box plots tell you about the relationship between the number of cylinders a car engine has and the car's fuel economy miles per gallon. So if you look, there's 4 cylinders. There is apparently one observation for what was reported to be 5 cylinders, which is interesting because I don't understand how 5 cylinders would work, but there may just be something I don't understand. 6 cylinders and 8 cylinders. Okay. So both the median fuel efficiency, miles per gallon, and the spread decrease from 4 to 6 to 8 cylinders. There is not enough information on 5-cylinder cars to include them in the discussion. The lower 75%, so everything Q3 and below, for the 8-cylinder cars correspond roughly to the bottom 25% of 6-cylinder cars. All of the 8-cylinder cars get less gas mileage than any of the 4-cylinder cars. The overall trend seems to be the greater number of cylinders in a car, the lower the fuel efficiency, which is not surprising. All right, let's look at problem 21. 3 statistics classes all took the same test. Histograms and box plots of the scores for each class are shown below. Match each class with the corresponding box plot. Okay. So step 1, identify the approximate value of medians of the histograms and compare with the box plots. So class 1 and class 2 both have medians a little higher than 60. Class 3 has a median in the upper 80s. Box plot A and B have lower medians, and box plot C has one in the upper 80s. Thus, class 3 goes with box plot C. So just by looking at the medians, we can make one match. Okay, so class 3 goes with box plot C. So the question is, does box plot A go with class 1 or class 2? And then B would go with the other one. Consider the spread of the distribution about the medians of class 1 and 2 to match the appropriate box plot. Class 1 has a bell-shaped curve, meaning that there is a higher frequencies for grades closer to the middle and lower frequencies as the grades move away from the middle. Thus, there is less spread in the middle 50% and more in the outer 50% as reflected in box plot A. Okay, it has the box itself is smaller, and so that would be one where there's a higher concentration around the middle. Okay, when there's not a lot of room in the box, that means that there's a whole high frequency right there, right in the middle. Thus, class 1 goes with class A, and class 2 with box plot B. Okay, that's it for the examples that we're going to go over on the video presentation. If there's some you want to go back and look at in your book, that would be great. Just make sure you bring your outline and your notes, or your outline augmented by your notes, to class next time, and you will work problems from chapter 5. I'll see you then.